Hello everyone, welcome to another kinetic tutoring episode. Today we're looking at another work problem, so let's just get straight into it. The prompt reads, a crane lifts a 425 kilogram steel beam vertically a distance of 117 meters. How much work does the crane do on the beam if the beam accelerates upwards at 1.8 meters per second squared? Neglect frictional forces. Alright, so let's just remind ourselves of a few key concepts before we dive into the problem. We know that work is the force that is being applied to the object times the distance that the force is being applied for. And additionally, let's draw our free body diagram. Here we have a crane, here we have the steel beam, and here we have our rope that's going to be bringing the steel beam upward. And finally, let's draw a free body diagram where the point is going to be our steel beam so we can visualize all the forces. There's only going to be two in this case. The gravitational force going downwards, and then we have the force of the crane. We're going to call that FC, going upwards. So I'm going to write this as FC here as well. So let's take a look at our net force equations really quickly in order to find FC. We know that our net force is written as MA, where M is the mass and A is the net acceleration of the object. We can write our A as 1.8 because that's been given to us in the prompt. And this is going to be the sum of all our forces, F of C minus mg. The reason there's a minus sign here is because the mg is going in the opposite direction of the FC. And so, from here we notice that there are this term here and this term here have a similar variable of m. We can just rewrite this g as 10. And so let's just move this over to the other side. We get m 1.8 plus m times g, or m times 10. We're just going to approximate that our gravitational constant is 10, and then we will get our crane force. So this means that our crane force is going to be m times these two numbers added together, which is 11.8. And that will be our crane force. So let's plug that into our calculator. Remember that the mass is the mass of the steel beam, which is 425 kilograms. 425 times 11.8 will get you 5,015. So I'm going to erase all of this so we have more room. 5,015 is equal to the force of the crane. And let's rewrite our work equation. It's going to be force of crane times the distance the crane moves it. And as we can see here, that information has already been given to us. So all we have to do is multiply these two numbers, 5,015 times 117, and this will give us our value for the work done on the steel beam by the crane. So let's do that really quickly. 5,015 times 117 will get you a value of 586,755. And remember that whenever we're talking about work, kinetic, or potential energy, the unit is going to be in joules. And let's take a look at these options here. It is clear that option A is going to be our answer because it is the closest. Here it has an insignificant figure formation. So we see if we move the decimal point over 5 times, we will get approximately 5.86 times 10 to the 5th. This will be our answer. The reason for our answer being a little higher than the expected answer is because we used 10 for gravity instead of 9.8, which is probably what the people creating the question used. But remember that when you are answering an FRQ in most AP Physics classes, a gravitational constant of 10 will be acceptable. Alright, that's all I have for you guys today, and make sure to tune in later for more physics tutorials.